Hi. So today we are going to talk about factless fact tables. So this is another concept in dimensional modeling, and which is very useful in modeling certain situations. Right. So let us start talking about factless fact tables. And most of the material has been taken from the Kimball's book. So factless fact tables. So facts are typically numeric measures. So that's what we have seen so far. Now, there are certain events which record merely the coming together of dimensional entities at a particular moment. And like, for example, a student attending a class. So when a student enters a classroom, right, so he knows that we know that what is the ID number, or what is the student's identification, what is the course identification, what is the day and hour, in which hour of the day he is going for the class, in which room he is going for the class, and for which instructor he is going for the class. So all these things are known, right? Now what kind of fact we can associate with this kind of an event, right? So there are no natural facts that come to mind. Student attending a class and a particular product and promotion. So when you put a product and promotion, there are hardly any kind of facts that we can actually store, right? And so these are events which need to be captured, and also these factless fact tables can be used to analyze what did not happen. So what we have is typically is a coverage fact table which talks about all possibilities, and then there is an activity table, say for example attendance, or for example sales, about events that did happen, right? And subtract activity from coverage, and say for example you want to find out products that were on promotion but did not sell, right? So these cannot be answered using the classical sales star schema with 4 dimensions: product, store, location, product, store, time, and promotion, right? So we cannot answer that using that particular schema. So we need some additional information which we store in a coverage fact table. Okay. So this is the background for factless fact tables, and we have taken 3 case studies in which we'll tell you the use of the factless fact table. So one is retail sales, so where I want to find out about which products were on promotion but did not sell, right? So those kind of products we want to find. In order management, we want to find the relationship between, or assignment of customers to representatives, or representative to customers, which need not necessarily result in a sale. And then we have attendance, where we talk about registration event and the attendance event. Right, so these are the case studies that we have, not the entire case studies, but the part of these case studies which require factless fact tables will be discussed. Say now let us look at the retail sales. So retail sales schema cannot answer an important question: what products were in promotion but did not sell. Sales fact table records only those SKUs that actually got sold, right? And it is not advisable to keep those SKUs in the sales fact that did not sell, because the sales fact table is already huge. So there are many records, many million records in the sales fact table. So it does not make sense to keep those products which did not sell also into this, because at the finest granularity level, right, so you will find that the fact tables are actually sparse in their keys, and there are only 10% on an average keys that get into the fact table on a particular day from a particular location, right? So they are already sparse, right? So so the fact table is already sparse in the keys, right? And so even with that 10% of products getting into the fact table every day, the total amount of data that is there inside the fact table is very, very huge. So it does not make sense for us to keep those products which did not sell into the fact table, because the number of products in a big online grocery store or online retail store could be very, very high, say 100,000 to 200,000 products, right? So introduce promotion coverage fact table. So for this we introduce what is called as a promotion coverage fact table, and it has the same key as sales. Sorry, this S is missing. As sales fact table, but the grain is different. Grain is different because the promotions are typically not at a daily granularity; they are typically at a weekly granularity. And fact table represents a product that was on promotion, regardless of whether the product sold or not, right? And this coverage fact table is an example of a factless fact table. Okay, so here I'm just recording which products were on promotion, irrespective of whether they were sold or not sold. So if you were to answer this question, what products were on promotion but did not sell, so it's a two-step process. So first what we do is we query the promotion coverage factless fact table to determine all the products that were on promotion. So here I get a set which is I call as P1, right, of all products that were on promotion on a given day, and then I query the sales fact table and find out which products were sold on that day, right? So I have two sets. One is P1, which is the set of all products which were on promotion, and P2 is the set of all products that were sold. So if I do a set difference, right, difference operator. So if you are familiar with relational algebra and the relational model, right, so you know what is the set difference. So set difference tells me P1 minus P2 tells me that rows that are in P1 but not in P2. So this would give me a list of products which were on promotion but did not sell. And I request, or it is strongly recommended that you try to write an SQL for this, right? And if you know the clause not exists in, so it would be easier for you, right? Or you write them as two separate queries and then take the difference of the results, so you can nest the queries, right? So this is the retail sales example. Then comes the order management. So this is where what we do is there is a customer representative assignment issue where you assign representatives to customers, and and it is not necessary that every assignment would lead to a sale. So it could be applied to a store, normal retail store, right, departmental store. When you walk in, a sales rep gets along with, comes with you, and he would try to explain things to you about the products, and then probably you buy products or you don't buy, right? So every interaction between a customer and a representative, or every assignment between them, does not necessarily lead to a sale. So what we do is we have a sales rep customer assignment fact. So here we have two dates. So one is the assignment effective date, that is from where it starts, and then we have the assignment expiration date, when the assignment expires. Then we have the sales rep key, customer rep key, and then we have this, please note this down. So this is a customer assignment counter, so which is set to 1. Okay, so with every row there is this, it is set to 1. So basically it is not a fact because it has the same value for every record that comes in, right? And so if you know relational databases, so if there is a column which has the same value for all the records, then probably you don't need that column. But we keep it here and we call it the dummy fact. Okay, dummy fact, and it is only to increase the enhance the readability of SQL. So when you do any kind of counting operations on this, so later I have an SQL query also which would highlight the use of this dummy fact in this. And then the other thing that you should note here is that this date, there are two date, this should be date, right? So there are two date keys in the fact table, so it is a case of role playing, right? So it's a case of role playing. So the date dimension is playing dual roles in this case. Okay, and then there is a sales rep and the customer dimension. So this is how the order management customer sales representative assignment fact looks like, and it's a factless fact table. So it does not, so if I talk about what did not happen, so it will not make sense if I for each sales representative or for each customer I try to record which representatives are not assigned to that customer, right? So that does not make sense, and vice versa also, right? So this is about order management. So sales rep coverage factless fact table allows us to answer queries like which assignments never resulted in sales, right? So you understand this. Now we come to the third case study, and here we have what is called a student registration, right? So what happens here is that students when they come, when they are admitted or when they come back for a new semester, so they are required to register for a set of courses that they would do in a particular semester. So here is the registration fact. Okay, so I am saying that this is also a factless fact table. Now you look at the keys that are present. So one is the term key, that is the term, or you can also call it semester key, term or semester key, right? Then there is a student key. So which student is registering for which semester or which term, so there is a student dimension here. Then there is a declared major dimension, so which major he belongs to. Then credit attainment key, so how many credits he has attained so far, right? Then there is a course key, right, which course he is registering with which faculty. And then you can see here at the bottom there is this dummy fact. Okay, so which is just to increase the readability of SQL, nothing else. And you can see the dimensions. There is a term, year, semester dimension, which is actually a conformed dimension. So when we go to the education case study or the academic data warehouse case study, so this is a conformed dimension. And then there is a course dimension, there is a faculty dimension, there is a student, and there are two other dimensions which are called as selected major, declared major, and credit attainment dimensions. So this is the student registration. Similarly, we also have the student attendance. So here again, let me clear. So both these things will come later also when we discuss the case study on academics, academic data warehouse. So what about events that did not happen? Say now I'm talking about student attendance. So you can see here, so there is a day hour key. So like in bits we have day, say Monday 1, right, Monday 2 up to Monday 9. Then you have Tuesday 1, Tuesday 2. So this is Monday is the day, and this 1 is the hour. So each hour, 1 means from 8 a.m. to 8:50 a.m. Hour 2 means 9 a.m. to 9:50 a.m. and so on, right? So we have classes till 5 p.m. So 9th hour is basically 4 p.m. to 4:50 p.m. So we call it the day hour. So there has to be a day hour key, because when I'm talking about attendance, student would talk about student would be attending classes in these hours, right? So we need to track which hour of the day and which day he is attending classes. So there is this day hour dimension, which is again kind of a conformed dimension with respect to the time dimension. Okay, so day hour key, and then you have the student key, then you have the course key, then you have the faculty key and the facility key. And you can see here the the dummy fact is there because it's a factless fact table, and it is attendance count is equal to 1. Now what happens, what about events that did not happen? Say we can use this attendance count as 0 or 1, right, 0 or 1 to model this. So 0 when the student did not attend and 1 when he attended. So once I put a fact that takes on two values, it ceases to be a factless fact table. So in that case it would not be a factless fact table. Okay, and it is called a reasonable, it is a reasonable approach in this case, because we are assuming that the number of the percentage of students who are attending classes is much higher than the student who are not attending classes, right? So it could be 90% and 10%. So accommodating 10% more rows could be done very easily, right? So now so what we have done so far is we have basically tried to look at excuse me, tried to look at three scenarios where we use factless fact tables. So excuse me. So records events which do not have associated facts, and dummy fact is equal to 1 is introduced to increase the readability of SQL, right? So suppose I want to do the select faculty and sum registration count and group by faculty. So if I did not have this registration count is equal to 1, so this query would have looked very odd, right? And it is used in retail sales, order management and education, etc. In some situations, event that did not happen can also be recorded, but then the fact table ceases to be factless, because if I am storing either 0 or 1 or some set of discrete values, then it ceases to be a factless fact table. So with this, I come to the end of this lecture on factless fact tables. Thank you.